Okay, we're in section 8 of the notes. It's trigonometric integrals. Basically, it's a section on recipes. These recipes work as advertised for the problems that we give you. All right, what's the problem with recipes? They may be hard to remember, and that's why things probably are written down for you. So when you look at these things, you can identify what you're looking for. Now, I'm going to say later in your careers, you're going to see integrals, and you're going to wonder if it can do it by hand. All I can say is, being resilient, in other words, trying something and then, hitting a dead end, backing out, trying again and again and again is not a bad option. All right. But over here, we're going to present, recipes for you. We'll go through some examples and then we'll reinforce it for you by going through more examples. So basically, we're going to give you a little lecture with some examples, and then we're going to go to examples. All right. So as you look at the stuff over here, I put in little boxes here, what the recipe applies to, and then we give an example. Sometimes it might be abstract for you, but we'll go to an example that make it concrete. So like number 1 says, power of sine is odd and positive, do this, and we'll go through that. Don't worry about that. Number 2 says power of cosine is odd and positive, we'll do that. All right. Again, we'll look for it. We're going to look for it. So, bottom line, I also go through some code here. Some of the code I go through is a Mathematica code. The school no longer has Mathematica. I wouldn't worry about that. Mathematica is a very important software package, though, but we no longer have it at Essex College because students just refuse to use it. But we do is we give you Sage code as well. And that's something that I've talked about repeatedly. All right. So, another number 3 says, power of cosine is blah, blah, blah. We'll go through it. We'll go through it. All right. So there's going to be some things to get through. And once we get through those things, including the tangent and secant, we'll get through that as well. I know it's tedious, though. I know recipes can be very tedious. It's like, what do you have in store? What are you going to do with it? We're going to do what they're asking us to do with it. That's what we're going to do. Then we'll get to the examples. The examples typically give you hints. All right. Just like here, we're giving you hints. What are hints? They're like recipes. All right. You got this, you do that. All right. We write problems that carefully work, by the way. So I'm going to switch to the whiteboard. I'll read through it and we'll do the examples and we'll try to follow what they said. All right, so let's go the whiteboard. And, certainly I'm going to talk about one problem at a time. And I realize sometimes you say, well, I can do this too. Well, in your future, you're going to be in schools where you are going to be doing this on your own. You're going to be doing most of the work on your own. It isn't, where the teacher's going to be reading stuff to you. But anyway, bottom line, let's talk about it. All right, so what do we got over here? Power of the sine is odd and positive. Well, what they say, if the power of the sine is odd and positive, what they say, save one factor of the sine and convert the remaining sines to cosine. Then it goes on to say, use U substitution to continue to solve the problem. Well, let's take a look at an example. All right, so the example over here, and I'll go through it with you. And again, the nice thing about the notes, they're written down for you. You can reread them as many times as you like. It isn't like someone just says it and they expect you to remember what they said. It's written down for you. So the first example is the sines power odd and positive. It is. So what am I going to do? I'm going to do what they say. They say save one factor of the sine and convert the remaining sines to cosines. So let me do that for you. So I'm going to save one factor of the sine. And that means I have a remaining factor of sine squared. Then we have cosine to the 4th, right? So what they say, save one factor of the sine and convert the rest to the cosine. Let me put that down for you. Well, what's sine squared? It's 1 minus cosine squared, right? That's what they said to do. And again, we're just reading a recipe to you. So we did what they said. The power of the sine was odd and positive. We saved one factor of the sine and we converted the remaining one to cosines. We did that exactly as what they were told to. Then they said, make a substitution. And the substitution they said to make was let U equal the cosine. That's what they said to do. So what's du? Well, that would be minus sine x dx. Well, lo and behold, if we take their suggestion, I'll write this down for you now. If we take their suggestion, what do we notice? Well, I'm seeing the sine x dx is actually minus du. I'll put this over here, right? So we just did the sine x dx, that's a minus du. And then what do I see? I see 1 minus u squared u4. Well, I'm going to keep moving. All right. So what I'm going to do now, I guess I should simplify the integral, right? Our little star is there for a reason to remind me to go back to the land of x's eventually. So what do you go over there? I guess you'd get, if you did the simplification, get u to the 6th minus u to the 4th du. I can certainly do that integration. It's super simple now. What do you get? u7th over 7 minus u5 over 5 plus c. What's u? Well, if you can't remember, go back and look at it. It's cosine. So write this down. So it's going to be cosine to the 7th of the argument x7 minus cosine to the 5th x over 5 plus c. I would strongly recommend that you still check the key. So what's key say? Let's look at it. I'm seeing it over here. Are they in agreement? Wow, miracle. It worked like look at charm, really does. All right, let's go to the next one. Next one says the power of the cosine is odd and positive. Okay, I'm thinking about that. Where they say one factor of cosine and convert the remaining cosines to sines. Well, you know what? Let's put this down. I think I'd be a little better at this one over here. Oh, look at that. They give me an example. And what's the example? Well, the example is as follows. The cosine, the power of the cosine is odd and it's positive. So what they said to do? They said, I'll write this down for you. This is pi over 6. This is a definite integral. Pi over 3. They said save one of the factors. I'll write that down for you. And then they said, I'm getting a little better at it. They said, rewrite the remaining cosines in terms of the sign. So what would be remaining? Cosine squared, that's going to be 1 minus sine squared x. Then you get dx root sine x. Now, what did they say to do? If you say, I can't remember, I didn't read it, whatever, you go back and read. So what they said was make a u substitution. And the u substitution I want you to make is u equals the sine of x. So du would equal the cosine of x dx. Well, the way I like dealing with definite integrals is I like to go completely to the land of u's if I can. Right. So one thing I notice is I got the cosine x dx, and that's du. Right. So I took care of this business over here. And 1 minus sine squared is going to be 1 minus u squared. I got that covered. On the bottom, what I get? I get the root of u, which is u to the 1/2. All right. Now I got to worry about the limits. So the first guy, pi over 6, right? Let me remind you what you did in Math 120. Most teachers said convert it to a degree measure because it's easier to understand it for most students. That's 30 degrees. They would say draw a 30-degree right triangle to help you with this. That would be 1, 2, root 3. And what am I doing? Taking a sine of that. And the sine of that's going to be 1/2. Now, I got pi over 3 now, right? I'll write that down for you. That's 180 degrees over pi. And what's that going to be? 60 degrees. And again, we're just reviewing what you did in Math 120. That's 60 degrees. Well, that's pretty simple. And what's the sine of that angle? Well, root 3 over 2. Put that down. All right, now here comes the claim. The integral should be much easier to deal with. I'll write this over here. This is 1/2 root 3 over 2. This would be u to the minus 1/2. I'm rewriting the integrand minus u. That would be 3/2, right? du. Let's keep going. Again, we'll look at the key later. I'm going to do the antiderivative. I'm going to add 1 to minus 1/2. That's 1/2 now. Divide by half is like multiplying by 2. Minus, I'm going to add 1 to the exponent. That's 5/2. Divide by half like multiplying by 2/5. 1/2. And that's going to be root 3 over 2. Now, granted, I always say this a lot to you. A lot of students are really struggling with big time with arithmetic. I'm not saying that I'm great at it, but I certainly want to see if I can do it. Let me see if I've got everything covered here. And let me just see if I did that right. Got to go backwards here. Yeah, I got to do it now. I hate to do I have to do it. All right. So let's take a look. It's 2. I got to plug this in now, right? So it's going to be, and I'll write this as a fractional exponent now. It's going to be 3 to the 1/2. That's a square root of 3, by the way, over 2 to the 1/2 power. I'll take care of that later, by the way. Minus 2/5. Now 5/2 is actually 2.5. So what do I get over there? √3 over 2 squared. And then I can write as 3 to the 1/2 over 2 to the 1/2 power. All right. That's the upper limit. And again, I'm going to repeat this. If you have trouble with arithmetic, you probably want to review it. But if you have trouble, I understand that people do have trouble. 2 square root of 1/2, which is √2. That's not so bad, right? And then when you get over here, minus 2/5. And then you get 1/2 to the 5/2. That's 2.5. So let's see, a half square would be 1/4. And then you get 1 over √2. All right, I got it's a problem. I want to say it's a problem. So this is going to be, let's see, you would have 2 over √2, which is just √2. I'll write that down for you. And then you get a 4th root of 3. Wow, it's crazy looking. What do you get over here? Well, I got to be careful. And let's see, √3 squared is 3. So I get 3/4 times 2. So 3/4 times 2 is 3/2. That's 3/10. Make sure I did that right. Yeah, I did it right. And then it's going to be the 4th root of 3 and √2 over here. All right. Again, I'm not done yet. There's so much arithmetic. When is it ever going to get done? Well, this is going to be √2 minus √2 over 20. I got to keep going. I hate to say it to you. I have to keep going. So let's write this down as √2, 4th root of 3, minus 3 √2 over the 4th root of 3 over 20. Let's see, plus √2 over 20 minus √2. All right, I got to get the 20 going here. It's work. All right, let's take a look at it. So 20 √2, 4th root of 3, minus 3 √2, 4th root of 3, plus √2, minus 20 √2. I'm getting close. Oh boy, this is going to be 17 √2, 4th root of 3. Right, I just did the first 2 terms. And the last 2 terms, minus 18 √2 over 20. This looks nasty. I'll be honest with you. I'm going to factor out the √2 though, because it just doesn't look right to me. And what do you get? 17 4th root of 3 minus 18 all over 20. Now, I guess that's over and again. Arithmetic really, although it's an important skill set, doing the problem, most of the work is coming from the calculus, but I still want to see if I got the answer right. Let's take a look at it. And they wrote down, you know what they did? They put the √2 on the bottom. I'm going to do that for you now. I don't know how they did that, but I'll do it. That would be 2. And that would be 17. This reduces 10 √2 on the bottom, and then you get 17 4th root of 3 minus 18. And I'm feeling pretty good about it. All right, I'm feeling pretty good about it. I got the same answer, didn't I? Whoa, I didn't. It says 19. I said 18. Where'd I go wrong? I see it now. And I'm glad I looked. And someone says, why are you glad you looked? I hate to make errors, I really do. And I'm going to point out to you, this is going to be minus 19, my mistake. Let me get my eraser out. Again, I'm getting my eraser. Again, I'm getting my eraser out. Whoops. Again, I'm getting my eraser out. Okay, made a mistake. Here's the deal though. Not bad. All right. By the way, it says I cheated to use a computer. Sometimes I do. Sometimes I do. And you still do simple arithmetic by hand, by the way. And someone says that's really nasty, but whatever. So I want to claim to you that for the students, and again, I'm trying to encourage this, take a look at Sage. Watch Sage do that problem. Watch how quick it does. All right. Watch how quick it does. All right. All right. Let's take a look at this one, number 3. Now that number 3 says, both the powers of the cosine and the sine is even and non-negative. Make these substitutions. All right. I want to go through this with you. And again, when I do this, I'm just reviewing what you did in Math 120. So let me write this down. Cosine, oh boy. So I'm going to write down the cosine of 2 theta is the cosine squared theta minus sine squared theta. I'm just reviewing identities that you know from Math 120. It's also equal to 2 cosine squared theta minus 1, and it's also equal to 1 minus 2 sine squared theta. So what they do is they realize that linear powers are easier to deal with than quadratic powers. So what they do is they write the sine squared and cosine squared in terms of linear powers. So let me just do one at a time for you. Cosine 2 theta equals 2 cosine squared theta minus 1. So this would be cosine 2 theta plus 1 over 2 equals cosine squared theta. Let me show you where that is over here. Right there. All right, let me do the other one for you. And you did these in Math 120 as well. So I'm going to write down cosine 2 theta 1 minus 2 sine squared theta. What's that give me? 2 sine squared theta equals 1 minus cosine 2 theta. So sine squared theta is equal to 1 minus cosine 2 theta over 2. All right. Now, the point of that is it takes a square, right? It's a linear problem, and that's written right over here. All right. So what I want to do is I want to see if I can do this problem here. All right. I really want to see if I can do it with their recipe. So what did they say to do? Well, they said, if you see, the powers of cosine is, I'm sorry, both powers of sine and cosine are even, make those substitutions. Well, I'm going to do that, but I noticed I got 2 of them. So I'll put them down for you. So it's really cosine squared x times cosine squared x dx. I'm not saying it's going to be easy for you, but just write it down now. What do you get? Well, cosine squared is going to be 1 plus cosine 2x over 2 times 1 plus cosine 2x over 2 dx. All right, I'm running out of room. All right, so I'll write this over here. I would get a 4. And then what do I get on top? I get 1. It's not so bad, actually. 1 minus, I'm sorry, plus cosine 2x plus cosine squared 2x. I got troubles. And let me go through the troubles with you. Before I get there, I want to go through them with you. And I make mistakes, and I want to plan on learning, right? So I get 1/4, 1 plus 2 cosine 2x plus, I'd have cosine squared again, right? So I guess I got to make that substitution again, right? What substitution are we talking about? The one above. So it's going to be 1 plus cosine of 4x over 2 dx. I got to work. And someone says, what's the work? I got to figure this out. I'm going to bring the quarter back in. 1/4 plus cosine 2x over 2 plus, let's see, that would be 1/4 times 1/2, which is 1/8, right? Plus cosine 4x over 8 dx. I'm just doing my chicken scratch. I want to keep simplifying it. 1/4 and 1/8 can be added together. That's going to be 3/8 plus cosine of 2x over 2 plus cosine of 4x over 8 dx. I can do my integrations now. What do you get over here? 3/8 of an x plus sine 2x over 4 plus sine of 4x over 32 plus c. I'm done. All right. So I'll put a circle on this indicating that's my final thing. And let's take a look, see how we did. All right. So I see I got the 3/8 of an x here. I got the sine 2x over 4, sine of 4x over 32 plus c. Not bad. It really kind of worked out as advertised. All right. So that's good. Now, so why are they working out so nicely? I hope you agree they work out nicely. We write them to work out nicely. We select problems that work nicely. So let's keep going. And I noticed that they got some Mathematica code over here. There's also some Sage code if you want to look at that. All right. So my claim over here, just give me 1 second. I got to do one thing. I'll be right back. Give you time for your brain to rest. All right, I'm sorry, I got distracted for a moment. I got to complete this out. All right, let's look at this one over here. And by the way, someone says, do recipes ever end? No. If you look at a typical cookbook, especially in mathematics, the cookbooks can be incredibly large, very complicated. That's what makes having machines so nice. The machines really store all these nice algorithms for us. So it says the power of the secant is even and positive. Save one factor of secant squared and convert the remaining secants to tangents. Wow. So let's put this one down. Let's write this one down. And I'll remind you of certain facts over here. So what do you get over here? And let's say it says power of secant is even and positive. Save one factor of secant squared. I can do that. I'll just write down one step at a time. Then I'd be left with a secant squared, right? I put x down. It's not x, is it? It's theta. Times tangent 4 theta d theta. All right. What do they say? They say rewrite the remaining, secants in terms of tan. Let's see if we can do that. So save one factor of secant squared and convert the remaining secants to tangents. Let me just remind you Pythagorean identities. And let me see if I can remind you that. So sine squared theta plus cosine squared theta is equal to 1. Well, I guess you could divide by cosine squared, right? What do you get? Tangent squared theta plus 1 equals secant squared theta. You could also divide by sine squared, and you get 1 plus, well, that would be what? Cotangent, wouldn't it? And then you'd have cosecant. Now, these are the same identities that you were given in math 120. All right, let's see if we can do that now. All right, so you're going to get equals 0 to pi over 4 secant squared theta. And then I'm going to write down what secant squared is now. What is that? Well, that's tangent squared theta plus 1, right? And then when I let off tangent 4, again, what's nice about it in the recipes in front of you, you can just look back over them and read if you want. They go on to say, let u equal tan. I'll put that down now. So I'm going to say u is equal to tangent theta. And what's du going to be? I hope you can remember it's secant squared theta d theta. All right, let's see if we can do it. And it's going to be equal. Well, I got to change the limits now. That's what I do anyway. So the tan of 0 is 0. And the tan of pi over 4 is 1. Boy, that was convenient. And then what do I get? Well, I see the secant squared theta d theta. That's just du, right? That was convenient. And then what do you get? You get u squared plus 1 u4. All right, things have gotten substantially easier. Again, the key here is that they're written to get easier. This can be u6 plus u4 du. This can be u7 over 7 plus u5 over 5, 0 to 1. And this is going to be 1/7 plus 1/5 minus the lower limit 0, so it's going to evaluate the 0. And what do you get? 35. And let's see, 5 plus 7 is 12, right? Let's see how we did. Gee, they don't have an answer. Go to the next page. Look for 12/35, right? Bingo. Did pretty good. All right, let's do number 2. I'll put it down for a number 2. Give me 1 second. I got to get rid of that. I didn't realize I was doing something there. But anyway, it says power of tangents odd and positive, save one factor of secant tan. Wow, a lot of recipes today, right? So let's take a look at this. So power of the tangent is odd and positive, right? Power of the tangent odd is positive. Okay. Save one factor. Oh, by the way, I'm going to go back to the heading of this listing over here. It's they involve, these integrands involve tangents and secants combined. All right. I'm sorry about that. I should have mentioned that. So let's say if we can do that. So here's what they said to do. Again, we're seeing about the recipe. Power of the tangent on positive is fifth power. Save one factor of the secant tan and convert to, okay, I have to do that. I'm going to save one of the factors of tangent. And I'm going to save one of the factors of secant. All right. Save one factor of secant tan. I did that and convert the remaining tangents to secant. Well, I haven't done that yet. Let me write down what I'm left off with though. I'm left off with tangent 4 and secant 4. I'm sorry, secant cubed. All right. I hope you can agree that those two integrals are the same. All right. So they said do that, but then they want to say convert the remaining secants in terms of tangents, right? So, the question is, have we done that before? I think we just went through the Pythagorean identities, right? So let me see if I can do that. Then you get tan 4, right? And then with secant, right? So let me just remind you that, tangent squared theta plus 1 is secant. You know what? I think, did I make a mistake somewhere? Let me see if I read that right. Oh, I'm sorry. I misread. And it says save one factor secant tan x and convert the remaining tangents to secant. I'm sorry, I misread my own recipe, right? Let me erase this. Sorry about that. So I have to convert the tangent to a secant, right? Let's go through that again. So tangent squared theta plus 1 is secant squared theta. So I'm going to write that tan 4 down as secant squared theta minus 1 squared. Or that'll be a fourth power times secant cubed. You know what? I put a theta down there and I apologize. Let me get that back. That's an x. And then we get secant cubed x dx. Now what they tell you to do, and again, if you can't remember, go back and read the recipe. All right. So I'm going to say u is equal to secant of x, and du is going to be equal to secant x tan x dx. Well, lo and behold, it looks like it's going to work out like a charm. Let's write this down. So what do you get? You get du, and then you're going to get u squared minus 1 squared u cubed. I know it looks awful. I got to do the limits of integration. So if the x is 0, the secant of 0 is 1. Let me just remind you, pi over 3, 180 degrees over pi. That's 60 degrees. I'll do my little right triangle over here. Root 3. That's 60, by the way, 2 and 1. And the cosine of that would be a half. So the secant would be 2. I'll put this over here. All right, so someone's going to say, has the integration gotten easier? And I hope you realize that this integration has gotten substantially easier. I still have to simplify it though. All right, let me go through that with you. 1 to 2. This would be, let me do an aside for it. U4 minus 2u squared plus 1 times u cubed. So what they give me? U7 minus 2u5 plus u cubed du. Let me get my eraser out, my side work. I don't like putting that there. And I got to do my integrations now. It looks pretty simple. And I'll write it down for you. That would be u to the 8th over 8 minus 2u6 over 6. We'll simplify later. Plus u4 over 4, 1 to 2. Let's put this down. Let's see, 8 is 2 cubed, right? So what do I get on top? I would get 2 to the 8th, which is 2 cubed, 2, 5. We'll do that later. What do you get over here? Well, this would be 3, right? And there would be 2 to the 6th. Again, I'll do it later. And then what this is going to be? It would be 2 squared times 2 squared over 2 squared. And again, I'll do that later. And minus, well, this is easy, 1/8 minus 1/3 plus 1/4. Let's do my arithmetic. 2 to the 5th power, because these cancel off, by the way, is 32. 2 to the 6th is 64/3. Plus, well, let's see, that would give me 4. That's pretty simple. And I got to do this over here. It's kind of crazy looking, but I got to do it. It's, I guess 24, right? And let's see, you get 3 minus 8 plus 6. Again, I'll do that arithmetic later. And what do you get over here? 32 and 4 is 36 minus 64/3 minus, this is 24, right? What would that give you? That would give you, let's see, 3 minus 8 is minus 5, 1/24. Yeah, I know it's tough. Yeah, but if you make a mistake, it even makes it worse. 24, let's write this down. 36 times 24 minus 64 times 8 minus 1. All right. Let's see if we can do the arithmetic now. I'm going to do something crazy. At least some people think I'm crazy when I do this. It's 24 on the bottom. I'm going to factor an 8 out from those two terms. And then you would get 3 times 36, which is 90, 108. And I factor in 64. This just makes it easier for me, but I'm not saying I didn't make mistakes. I think I spend more time on arithmetic than I do on calculus. This is 8. 36 and 8 is 44. Minus 1, 24. That's 320 and 32, 352. Minus 1, 351. Boy, let's hope I didn't make a mistake. Gee, it's not even on that page. And I think I made a mistake. Whoops. Sorry about that. Oh, it's divisible by 3. Let me do that then. Sorry about that. 3 goes into 24 8 times. Let me show you 3 goes into 351. The next page. Bingo, we got it. All right, so I'm going to say it's a lot. I know it's a lot. So someone's going to say, I can't remember everything. The part about recipes is not to remember everything, is to realize that, you're given some ingredients, try something. We give you some things over here to try. Again, I'm not big on memorization, but the bottom line is try. All right. So next thing we're going to cover is going to go to examples. And when I do the examples, I want to make sure you're paying attention to me giving you hints. And that's important. Take the hints. However, you're free to choose. You don't like my hints? Take your own hints. Okay? Thank you so much.